Hello everyone. In this video we will see how to record our audio signal in the MATLAB. So first of all we have seen that what the audio signal is in the previous lectures. We know that what is an audio signal. So actually the audio signal is an analog signal, and now we are going to record this signal in a digital device which is a laptop. So laptop will convert this analog signal to the digital by using analog to digital converter. And the thing is that we will speak in the microphone, and then microphone takes this signal to the analog to digital converter, and then it is stored in the MATLAB in the memory of the laptop. So there are a number of things that we have discussed before, that we need a few parameters. What are these parameters? So let's say the first thing that, because we have this signal which will be the function of time, okay, and this will be like a waveform, and it will be stored in a vector which is like x of t. So what we have to do, let's say the first thing is we have to set a few parameters. And what are these parameters? These are the recording parameters. So what are these parameters? The first thing is the sampling frequency, and by default this is 44,100, which is the standard one for the audio. Okay, so this is the first number that we will adjust. And if you remember, we discussed that the sampling frequency is determining the sampling period, which is the sampling period after which we will take one sample of this signal. And we said in the previous lecture that this sampling frequency should be following the Nyquist criteria. And the minimum Nyquist criteria is that the sampling frequency, the Nyquist frequency, is half of the sampling frequency. So it is like the sampling frequency should be 2 times of the maximum frequency present in the signal. So is like this. And now you know that we are recording an audio signal, which is something that a human can hear, and the frequency range that human can hear is 20 to 20 kilohertz. So in this way the Nyquist frequency should be, in our case, is like 2200 and something like 50 hertz, so which is more or less near to this range. So these numbers make sense. So this is one of the points that you should know, that why the sampling frequency is set to this standard, and we are automatically following the Nyquist criteria by setting the frequency to this standard. So the sampling frequency is 44,100. And in MATLAB we use the semicolon so that the output will not be displayed at the command window. And I will show you that what I mean by this when we will go to the MATLAB and we will work there. So the next thing is that we have to define the number of bits. The number of bits by default we can say are 16, which means that there are 2 raised to the power 16 quantization levels. And what I mean by quantization levels is you have this signal and the y-axis have these quantization levels. So the amplitude values are this much, which are too much for the time being. Okay, but this is something we set. And then the next thing is we say that the channel is single. For the moment we are not going into the details of that, but we say that channel is one, which is mono channel, not the stereo one. Okay, so the next thing after that is in MATLAB there is a built-in object for recording a voice. Let's say I want to store my audio in this variable a, and I call this object which is a audio recorder, and I pass just a moment. And I pass these parameters into this object, which is the sampling frequency and number of bits. So okay, we have to is okay, so the n number of bits, and then we have n channels. So this will create an object with this specification. When we will go into the MATLAB, we will see in detail that how after creating this object with these parameters the variable a looks like, and I will show you in much detail. Now we have already created an audio recorder with the specifications, and now we have to start recording our voice. But before that, there is another important parameter that we have to define. And what is that parameter? That for how long I want to record my voice, which is the duration, and the duration is let's say 5 seconds. So the percentage sign is used for comment in MATLAB. So duration is a variable in which we will store a number which is 5, and 5 will be the duration of this signal. Now let's say I want to display that now the recording will start recording. This is just like a string which will be displayed, and now I call another object which is record blocking, and in this object I pass an object which is already created by audio recorder and is stored in the variable a with the duration. So I want to record an audio with these parameters of this duration. Okay, this is the concept that we have to see. And now after that the audio is done and we have to stop the recording. So up till here we have defined the parameters, we have recorded our voice with respect to those parameters, and now the next thing is that now let's look at what this voice look like, or maybe we can listen. How can we listen? Simply we can say play a, because a is a variable in which the audio is stored automatically. Now the next thing is that I want to get the data of this audio file, and how can I do that? Let's say I create another variable which is data of a, which is an object. So there is another object in the MATLAB which is more like maybe a function, and in this object we will pass the data of the already created variable a, which contains the data of an object. So now we have the data in this vector, and we will see that in the MATLAB when we will go, we will see that how these vectors look like. I will show you in much detail. Okay, so the next thing is now we have the vector and we can save this file, this vector in the form of musical file. And how we can do that? First of all, I say that let's do, this is my audio. This is the name with which I want to save my file, and this is the format with which I want to save my file, which is .wav. And now I can use an object which is audio writer. So I pass the file name, and then the other thing that I can pass is data. Then the next thing that we can pass is data in the variable a, and the sampling frequency, which is very important. So this is one of the things that we have done. We have recorded our voice and we have played our voice, and then now we have stored our voice in the MATLAB. So the next thing is we can also plot this voice and see that how it looks like. But before that we have to define the time interval. And what is the time interval? Now let's look at few things. We have taken fs samples, and these are the samples in 1 second. Okay, and the duration of our signal is 5 seconds. So how many samples our signal has? In total our signal has this much samples. And if I want to define the ratio, if I want to define the duration, the time interval of our signal, which is like the signal starts from 0 and then it goes to, it has total this much of samples. Okay, this is the variable a, data of a. It has this much samples, and because it is starting from 0, so we have to subtract from 1, and then we say that this is now divided by the samples fs, which are the samples in 1 second. So now this is what? This is actually an interval from 0 to 5 seconds. Okay, which makes complete sense because the length of the data is what? Length of this data of a is the maximum number of samples, and if I divide, it's the maximum number of samples, which are actually 5 of s, and if I divide this with f of s, then we are left with 5, and the signal is starting from 0. So this is how we can define the time. So the time interval is from 0 colon is like an increment, and we have to go to the point of, this is the maximum point till which we have to go, a of data, and this is the length. So from this we have to subtract 1 because we are starting from 0, and then we divide this with f of s, which is the sampling frequency. Okay, now we have signal, and we draw this signal with respect to the time, and the signal is in a of data, and then we can do the x labels, y labels, and the title of this signal, which we will see when we will go to the MATLAB. So the next thing is we have seen the time domain plot of this signal. Time domain plot of recorded signal. Now I want to see that how many frequency components are present in this signal. So we will use the Fourier transform. For the time being, I am not going into the details of that, but you can see the details of Fourier transform in my next few lectures. So in simple, Fourier transform will tell you the frequency components present in the signal. So we will use the command FFT in the MATLAB for this. Let's say how we do that. First of all, we will see that how many samples are total there, which is length of A of data. Then we take the Fourier transform, which is A of data. This is actually the first Fourier transform, which is an optimized form of Fourier transform. Then there is one of the thing which you will not understand maybe now, but if you study the Fourier transform in detail, you will understand that when we take the Fourier transform, it exists at the negative side and also at the positive side. But when we use this command of f of t, it gives you the Fourier transform all toward the positive side. So we have to shift this to the center, and for this we use a command which is fft shift, in which we pass this variable y, which contains the Fourier transform of this. So it is simply like shifting a zero frequency component to the center. And now to plot this, we have to define the x-axis, which is the frequency. And how can we define this? We have total n number of samples, and out of these n by 2 samples are on the negative side and n by 2 samples are on the positive side, and there is also a 0 sample, so we have to subtract 1, and then we have to multiply this with the just a moment. Okay, we have to multiply this with the sampling frequency divided by total number of samples. So the next thing is that we have to plot this, and in order to plot this on the x-axis we plot frequency, and then on the x-axis we plot the absolute values of the Fourier transform, because it can also contain complex numbers, which this is why we have to take the absolute values. Okay, and then what we can define x label, y label, and the title of this. So now we will see that how this can be done in the MATLAB. I will show you everything in detail, so don't worry about this. I just showed you here because I think it was much easy to follow the concept and everything. So now we know everything, that how can we define the signal in the MATLAB and everything. Now in the next part of this video we will see that how we can define this in the MATLAB, and we will go through every detail what's happening there and all that stuff. Okay, so just follow me. So here we have a MATLAB. So first of all, the things that you should know is in MATLAB there is a command window, which is this area, and in the command window whatever command that you will execute will run at the same time. Like I say that a is equal to 4, and then there is a semicolon, so that this output will not, the output of this variable will not be printed in the command window. And you can say that when the command is executed, a is equal to 4. Here in the workspace this value appeared, which is a is equal to 4. And then there is a current folder on the left side in which you have to save the script. Script is like a sequence of commands that you have to write, and after that you run that program, and that sequence of commands give you some results. So this is like this. So let's say I have to do all the stuff that we explained a bit earlier. So how we can do it? So the first thing is we have to create a script. And how can we create a script? First of all, I create an script file with, let's say, name audio recording. So this is saying that there is no file which exists with this name. So do you want to create this file? Yes, I want to create this file. And now the first thing is defining the variables that we have already discussed. And what are these variables? The first thing is the sampling frequency, which is 44,100. The next thing is number of bits, which are let's say 16, which we have already discussed, and then the channels is 1, which have been already discussed also. So now we create an object with this file, with this command, which is audio recorder. So here it is, audio recorder, and then in this we pass these variables, which is the sampling frequency, number of bits, and then number of channels, which is 1 for the time being, and we put the semicolon here. So let's see, we want to look at the output, what is stored in this variable a. So first of all, I will clear this workspace, which can be cleared by this command. No, this command is used to clear the command window, but for the workspace you have to use this command, which is clear. Let's say I run this program and see what happens. So first of all, we run this, and after running this you can see that the variables have appeared in the workspace. The sampling frequency is 44,100, number of bits is 16, number of channels is 1, and then there is an object which is created with a variable name a. And let's see what is inside this object. Just a moment, if I put this here so we can see it easily. Let's print this variable. What is inside this? So you can see this is an object audio recorder with the properties that we have already set. The sample rate is 44,100, number of bits 16, number of channel is 1, and all other parameters are set in a default way. So we just need to focus on the variables that we have set, and all others are by default. So let's move to the next step. And what is the next step? Just a moment, if we put it there. Okay, so the next thing is we have to define the duration of this signal, and I say that the duration of this signal is equal to 5, which is 5 seconds. Let's say this is seconds. Okay, then we have to start recording, which is this one. And now we call the block record blocking. Okay, record blocking, and in this function we pass the object which is already created, and the duration, which is the time for which we want to record, and then we say that display stop recording. So let's run these lines and see what happens. So now the recording has started and everything that I am saying is recorded. Okay, so let's see what is now stored in this variable a. Let's go back again here and let's print a in the command window. So now you can see that data is stored in this variable, and what you can see is that the total number of samples are this one, 220,500, which is if you multiply the sample rate with the duration of the signal, you will get this many samples. We can even verify this here, which is the duration of the signal is 5. Let's say I simply say 5, and then the samples taken per second are this much. So this is equal to 22,0500. So this verifies. So the next thing is what? So the next thing is we have to take just a moment. Okay, so the next thing is we can play this audio file, but for the moment we are not playing it. I will just say that I use this variable, but then I put it in the comments, which you can use it, and then I say that let's get the data, which is get audio. So this we have to get from object A, and then we say that we want to store this with name my audio dot wave and put the semicolon so that every time output is not printed at the command window, and then we write the file as file name A of data and the sampling frequency, which is taken as f of s. Okay, and after this, if I run these lines, you will see that a file will appear here in the current folder. Let's do it. Okay, so what is the error? Okay, so this variable is a actually. Okay, so there is again an error. What is the error? Okay, so this is file name. Sorry for the errors. Okay, here it is. This is a file. Here you can see the file myaudio.wav. It is stored here. So the next thing is we want to visualize this signal. So in order to visualize this signal, we have to create the timeline. And what is the timeline? Which is the time starts from 0 and it goes to the length of A of data and all this we have to subtract this -1 because there is also a 0 sample, and then we divide this with the number of samples. So the time will be from 0 to 5, which is the duration. And then I say that you can plot this signal as a plot of time, A of data, simply, and then we adjust the line width as 2, maybe no 1.5 maybe. Yes, and then we say X label is time, which is in seconds. Y label is, let's say, Y of t, and the title is time domain audio signal. So now if I run these lines, what happens is, okay, so this is f of s, right? So before doing this, I create a figure here, which is figure number 1, let's say. So if I can show you that this is the plot. Here on the x-axis you can see the time in seconds, and on the y-axis you can see that the signal has the amplitude values from minus 0.15 to 0.15, and this is the time domain signal. Here you can see the voice which I have recorded. Okay, so the next thing is we want to see how this signal looks like in the frequency domain. And how can we do that? It's the same thing which I have already told you, but now we will look at in the MATLAB. So first of all, we have to define the total number of samples, which is the data vector, the length of the data vector. So this will be the n number of points, and then the next thing is we take the FFT of this data vector. Then we have to shift this in the center, so we have to use FFT shift command in the MATLAB for this variable y. And then the next thing is we have to define the frequency axis. And what is the frequency axis? It starts from n by 2 points on the negative side, okay, and it goes to n by 2 points on the positive side, and we subtract 1 point because of the 0 sample, and we multiply this with the sampling frequency by the total number of samples present in the signal. Okay, and then now we can plot this signal. On the x-axis we have frequency, on the y-axis we have y shifted. Okay, and we can say that the line width is what is 1.5, and then we can set the x label, which is frequency in hertz, and then I can set y label, which is frequency domain audio, which is actually you can say y of f, and now this is the magnitude of y of f because we are taking the absolute values. And then you can set the title as frequency domain audio signal. Okay, and then the little thing that you can do is generate the figure 2 in which we see this so that it don't overlap with the figure number 1. So now when I run this, I hope there is no error in. Okay, now there is one thing which is this. Okay, now if I run this, okay, we have taken absolute. Okay, we are not plotting the absolute. Okay, no, we should plot this absolute because we are getting the warning that this variable has imaginary part, okay, which is important. So now if I run this again, so I will get this plot which is here. So on the y-axis you can see the frequency in hertz, and on the y-axis you can see the magnitude of each frequency component. So it is just telling you that this frequency component is present this much strongly in the signal. So this is how we record the signal, and then we do the time domain analysis, and then we do the frequency domain analysis, which tells you that which frequency component is present with what magnitude. So this is it from my side, and see you in the next lecture. Thank you very much.